Hello everyone. So we'll continue problems on general equation of line and also various forms of equations of line. Okay. So see the next question, students. A line through the point h, 3 and 4, 1 intersects the line 7x minus 9y minus 19 is equal to 0 at right angle. Find the value of h. Let me take a rough picture of this first. Okay. Line through the point. We have one line through the points. What are the points? H, 3 and 4, 1. Okay. Intersect the line. This line intersects another line at right angle. So can I take another line like this? Because this intersect this line at right angle. So equation of this line is what? 7x minus 9y minus 19 is equal to 0. Then find the value of h. You need to find the value of this unknown h. See, the line through the points h, 3, 4, 1 intersect the line 7x minus 9y minus 19 is equal to 0 at right angle. Find the value of h. So we need to find h, value of unknown h we need to find. Here students, consider the equation first. Let 7x minus 9y minus 19 is equal to 0. So is it 9y is equal to 7x plus 19? See, 9y is equal to 7x minus 19. Throw divided by 9. So y is 7 by 9x minus 19 by 9. I mean, from this equation of line, can you take slope first? What is slope here? So, slope of 7x minus 9y minus 19 is equal to 0 is 7 by 9. Am I right? Slope of this line is 7 by 9. Then slope of this line will be what? It will be its negative reciprocal, isn't it? Slope of this line will be negative reciprocal. Why? Because these two lines are perpendicular to each other. So can I write? So slope of line perpendicular to this is, this equation is minus 9 by 7, isn't it? Is 7 by 9 and minus 9 by 7 are negative reciprocal of each other? So can I take the slope of line perpendicular to this is minus 9 by 7. So is it perpendicular line, students? Can I take slope of this line as minus 9 by 7 now? Did you get why I considered slope of this line first and slope perpendicular to this line? Now see, for this line 2 points are given. Here the question is to not find any equation. Here we need to find unknown value, isn't it? For this line, 2 points are given. Can you find slope? Of course you have already slope. Can I equate the slope when 2 points are given to this? See, slope of line passing through. What are the points? H, 3 and 4, 1 is, what is the formula, students? Let me write it here. M is equal to y2 minus y1 divided by x2 minus x1. I am using this formula here. So is it, let me take this as x1, y1 is as x2, y2. So is it 1 minus 3 divided by 4 minus h. This is equal to, can I consider this is equal to minus 9 by 7? Because slope of line passing through these 2 points, this line is nothing but actually what? Slope of a line perpendicular to this line. Because these 2 lines are perpendicular to each other. So can I equate slope of a line passing through these 2 points as minus 9 by 7? And now the rest is what? Simplification part. Can you simplify this and can you get h value? Did you get the problem here, students? First we will consider the equation. We will consider its slope. Then slope of its perpendicular line will be minus 9 by 7. Perpendicular slope of this line. And when 2 points are given, you know how to find slope from the formula. I have written the formula here. M is equal to y2 minus y1 divided by x2 minus x1. Can I equate this to this? Isn't it? Because this is also slope of its perpendicular. This is also slope of the perpendicular line passing through these 2 points. The rest is simplification part. So this is just a rough picture. Let me continue here itself. Before that, it's better if you write that rough picture, okay? Implies, let me simplify this. Is it minus 14 is equal to minus 9 into 4 minus h? Isn't it? This is minus 2 into 7. Minus 14 is equal to minus 9 into 4 minus h. So minus 14 is equal to minus 36 plus 9h. Isn't it? So 9h is equal to, it will be 20. So h is equal to 22 by 9. This is the value of h. Let me check. Yes, this is the value of unknown h. So first take a rough picture, then it will be easy for you to think what we need to find here. Let's see the next question. Next question. Two lines passing through the point 2, 3 intersects each other at angle of 60 degree. If slope of one line is 2, then find equation of other line. Let me take again a rough picture of this. Two lines passing through the point, common point, isn't it? Because both the lines are passing through this point, so can I take common point? Point of intersection as 2, 3 intersects each other at an angle of 60 degree. At an angle of 60 degree. So angle between two lines is given. Slope of one line is 2. If I take this as line 1, slope of this line, can I take m1 as 2? Then find the equation of another line. You need to find the equation of another line, isn't it? See, in the picture I have written what is given and what you need to find. Point of intersection of two lines given, angle between the two lines given, slope of one line is given, you need to find equation of another line. See students, to find equation of line, minimum what we need? We need a slope and point. Point is already known because 2, 3 is a point of intersection of two lines. So 2, 3 is also point of this line, isn't it? Point is known. Only thing is you need to find slope. So angle between two lines is given, one of the slope is given. Can you find another slope? So we'll write the formula. Tan theta is equal to, did you get? Why I am using this formula here? Because one of the slope is known, angle between them is known. So tan 60 degree, because angle between them is 60 degree, modulus of m2, I don't know, isn't it? This is the slope of a required line. m2, m1 have taken, see, minus m1 is 2 divided by 1 plus, again 2 m2, isn't it? So it's better if you write let slope of one line be m1. Is it fine? If I mention it will be better, isn't it? So I have taken slope of one line as m1, so the another line will be m2. And now if you solve this, of course you will get m2 value, isn't it? Implies tan 60 degree. So what is sine 60? Root 3 by 2 and cos 60 is half. So is it tan 60 is root 3? And let me eliminate this modulus. So the modulus possible values are both positive and negative. Can I add positive, negative here? Which is equal to, now let me neglect modulus. m2 minus 2 divided by 1 plus 2m2. Isn't it? Since I have removed modulus, see I have taken plus or minus 2 here. Or you can take here also. Simplification will be more easy if I take here. That's it. Isn't it? Now, we cross multiply. I mean, we have two set of equations now. Let me write both the equations. So, before starting the problem, I hope you have taken this picture. This picture actually helps you more, isn't it? So, pause the video and take this picture. Let me erase this. And also this. Okay, let me continue now. So now two possible. One is root 3 is equal to m2 minus 2 divided by 1 plus 2 m2. And another case is what? Let me write it here. Minus root 3 is equal to m2 minus 2 divided by 1 plus 2 m2. Is it fine? I've taken both the cases. So when you cross multiply this, so what you will get? Root 3 plus 2 root 3 m2 is equal to m2 minus 2. So m2 will be, can I write, m2 will be 2 root 3 minus 1 is equal to root 3 plus 2. Is it right? See, 2 root 3 m2. Let me shift this to LHS. Then have written reverse order. M2 1 minus 2 root 3. Isn't it? Is it fine now, students? Let me shift this to LHS. So root 2 plus 2, have written it here. And when you shift this to that side, 1 minus 2 root 3, and m2 is common. So m2 is what? Root 3 plus 2 divided by 1 minus 2. One of the m2. Similarly here, what you will get, 1 more m2 will multiply, cross multiply, minus root 3 minus root 3 m2 is equal to m2 minus 2. So again here it will be root 3 plus 2 is equal to m2 into 1 plus 2 root 3. So m2 will be 2 minus root 3 divided by 1 plus 2 root 3. Isn't it? So we have two values of m2, two slopes, isn't it? So we have two slopes. We have to find equation for both the cases. Okay? This is a little big problem, students. First we'll find slope of another line. Next we'll find equation of line in both the cases. Okay? So first copy this. Next let me find equation of line in both the cases. Pause the video and copy the entire. So we have two cases. The one is m2 value of this, and another case is this. Okay, let me take it that way only. First case 1. Case 1. When equation of line passing through, what is the point, students, given? Passing through 2, 3, and slope is what? Slope is root 3 plus 2 divided by 1 minus 2 root 3 is given by, I am using this as slope for case 1. Similarly, I have to use this as slope for case 2. Remember. So it's given by y minus y naught is equal to m into x minus x naught. This is the formula, isn't it? Let me directly substitute it. Y minus 3 is equal to m is root 3 plus 2 divided by 1 minus 2 root 3 into x minus 2. So it will be 1 minus 2 root 3 y, and this will be minus 3 into 1 minus 2 root 3 is equal to, this will be 2 plus root 3 x minus 2 of root 3 plus 2. Isn't it? I cross multiplied it. And it multiply element wise. Let me continue here. And remember the second case, what you are using slope for second case. So when you do this, what you will get? 1 minus 2 root 3 y minus 2 plus root 3 x is equal to, is it 3? I am multiplying this. Okay? 3 and minus 6 root 3. This will be minus 2 root 3 and minus 4. So the equation is 1 minus 2 root 3 y minus 2 plus root 3 x is equal to, this will be minus 1 minus 4 root 3. This is the equation of the line when the slope is what? root 3 plus 2 divided by 1 minus 2 root 3. Similarly, have to do case 2 now. Okay? Similarly, have to do case 2. Case 2 is what? Equation of line passing through 2, 3 and slope is this. I hope case 1 is over. Pause the video and copy the students. Let me find equation of line passing through same. Next I am doing case 2. Passing through the same point with slope. Slope is different. What is slope? 2 minus root 3 divided by 1 plus 2 root 3 is given by. I am doing case 2 now. Case 2. So what you will get here? Y minus 3 is equal to 2 minus root 3 divided by 1 plus 2 root 3 into x minus 2. When you cross multiply this, 1 plus 2 root 3 y, and when you multiply this element wise, minus 3 minus 6 root 3 is equal to here 2 minus root 3 x, and when you multiply this element wise, minus 4 plus 2 root 3, isn't it? Minus 4 plus 2 root 3. So let me continue here. It will be 1 plus 2 root 3 y minus 4 minus 2 root 3 x. I am writing in terms of x, y and constant. Okay. So y x is equal to, in RHS, let me shift constant in RHS. What you will get? Minus 1, because minus 4 we have minus 3. Shift this RHS, it becomes minus 1. So this will be 8 root 3. So this is the equation of line when slope is m2 is 2 minus root 3 divided by 1 plus 2 root 3. So in this problem we got two values of m2. Yes, you have to find equation for both the cases. Okay. So this is the solution. It is little big problem, students. Once again, just rewind it and see the problem and copy this. Okay. We'll see the next one. Next question. Find the equation of right bisector of the line segment joining the points 3, 4 and minus 1, 2. Find the equation of right bisector. Right bisector means which bisect another line at right angle. That is the meaning of right bisector. I mean, if you have like this, right bisector will be this. Is it clear? Angle between them is 90 degree, and right bisector means it is dividing the line in equal parts. Okay, that's why it is right bisector. Let's understand what is right bisector here. Find the equation of right bisector. This I have to find. Okay, equation of this. Equation of this I have to find. Of the line segment joining the points, we are finding equation of right bisectors of line segment joining the point. What is the line segment, students? Joining the points 3, 4 and minus 1. Is it clear? Did you get the point here? You are finding the equation of this line. This is actually what? A right bisector for line segment joining 3, 4 and minus 1, 2. So you need to find equation of this right line. Again, to find the equation of line, what do we need? Minimum what we need? We need point and a slope. Point on the line and a slope. See, the line joining these two points is given. Since this line is a right bisector of this line, the point of intersection of these two lines will be the midpoint of a line segment joining 3, 4 and minus 1, 2. Am I right? Is it this is midpoint of line? Am I right, students? Because this line is what? Right bisector. So angle between them is 90 degree, and this line dividing this line segment into two equal parts. So is this midpoint? I mean, if you know the midpoint, if you know this point, because this point is passing through this line, and if you get slope, then easily you can find equation of this line, isn't it? First, let me find point and the line. Next we'll find slope. Later we'll find equation. This is the procedure. Solution. First, since line, let me give the line L, okay? Since the line L is required line, we need to find equation of this one. So I am writing required line bisects line joining the points 3, 4 and -1, 2, isn't it? So midpoint of this line will be, I am using midpoint formula. So is it 3 minus 1 by 2, 4 plus 2 by 2, isn't it? x1 plus x2 divided by 2, y1 plus y2 divided by 2. So it will be what? 1, 3, isn't it? So this is the point of this, isn't it? This is the coordinate of this point. And this point is intersection of both the lines. So can I say 1, 3 is on the line L? Yes. So 1, 3 we have a point on the line. Now we'll find slope. See, can you find slope of this line when 2 points are given? And if you know the slope of this line, can you find its perpendicular? Isn't it? So slope of line joining 3, 4 and -1, 2 is, which formula I am using? y2 minus y1 divided by x2 minus x1. So 2 minus 4 divided by -1 minus 3. So -2 divided by -4, is it half? Half is what? Slope of this line, isn't it? Half is slope of this line. See, slope of line joining 3, 4 and -1, 2 is 2 minus 4 divided by -1 minus 3. Is it half? So slope of line perpendicular to it, that is L, isn't it? Slope of line L is its negative reciprocal, isn't it? Is it -2? See, we have point on the line, we have slope of the line. Now can we find the equation of the line, students? Isn't it? So finally, equation of line passing through, what is the point here? 1, 3 with slope -2 is, what is the formula? Y minus y0 is equal to m into x minus x0. Y minus y0 is 3 is equal to m is -2 into x minus x0 is 1. Isn't it? And when you simplify this, you will get required equation of line. We have used 3 formulas here. One is to find the midpoint of the line, because this point is actually also a point passing through this line, isn't it? So from midpoint formula. Next is slope when 2 points are given. I used slope when 2 points are given formula, and also equation of a line passing through the point and slope is, what is the formula? Y minus y0 is equal to m into x minus x0. I am repeatedly telling you the formula, I didn't write here, okay? So we'll simplify that, you will get the equation. Now the picture is not necessary now. Let me erase this. I am continuing here, okay? Y minus a is equal to -2x plus 2. So we say 2x plus y minus 5 is equal to 0. This is the equation of right bisector of the line segment joining the point 3, 4 and -1, 2. So I have written everything here, okay? Just follow that. And the rough picture actually helps you, isn't it, students? What I wrote for a rough picture actually helps you. It helps you to convey the concept easily. See the next one. Next question. Find the coordinates of foot of perpendicular from the point to the line. Imagine you have some line. Let me take like this. Okay. Line. What is the equation of line? 3x minus 4y minus 16 is equal to 0. We need to find the coordinates of foot of perpendicular from the point. We have one point here, minus 1, 3. So what we need to find? Foot of perpendicular. So this point you need to find. This is the question, isn't it? Read the question carefully. Find the coordinates of foot of perpendicular from the point minus 1, 3 to the line 3x minus 4y minus 16 is equal to 0. Did you get the question, students? You need to find this point here. Just observe, this is actually point of intersection of these two lines. And since they are given perpendicular, foot of perpendicular, the angle between these two lines is 90 degree. Understand the concept first. Okay? So we need to find this point here. So first we'll consider the equation. Equation of given line. So let 3x minus 4y minus 16 is equal to 0. Let me try to find slope of this line first. So 4y is equal to 3x minus 16. So we divide 4 by 4. 3 by 4x minus 16 by 4 is 4. So slope of, what is the line? 3x minus 4y minus 16 is equal to 0 is 3 by 4. Slope of this line is 3 by 4. Is that clear? Then slope of its perpendicular line is minus 4 by 3, isn't it? The slope of its perpendicular line will be what? It's negative reciprocal. Is it minus 4 by 3? Isn't it? I mean, the slope of this line is minus 4 by 3. See, you have slope of this line and you have point on the line. Now, can you find the equation of this line? Wait, we are actually not finding equation of this line. We need this point, isn't it? Foot, I mean, the foot of perpendicular from the point. We need this point actually. But this point is also intersection of these two lines, isn't it? If you get equation of this line and you already have equation of this line, and when you solve these two equations, actually you will get a point of intersection, isn't it, students? Did you get the concept here? If you solve these two equations, then you will get the common x and y value. That is what? Point of intersection, and that will be the required point here. So I am trying to find equation of this line. So we have slope of this line, and we have point. We find equation. So equation of line passing through. What is the point? Minus 1, 3, and slope minus 4 by 3 is, okay? Let me continue here. Pause the video and just copy this. Let me continue here. Is, what is the equation? Y minus 3 is equal to minus 4 by 3 into x minus of minus 1 plus 1. Did you get the formula? Which formula used here? Y minus y naught is equal to m into x minus x naught. So this is the point, x naught y naught, this is m. So it will be 3y minus 9 is equal to minus 4x minus 4. So is it 3y plus 4x minus 5 is equal to 0? This is what? Equation of this line, isn't it? So equation of line perpendicular to this. So let me continue here. So this is equation of line perpendicular to 3x minus 4y minus 16 is equal to 0. What we need? Coordinate of foot of perpendicular from this point. We need this point, isn't it? It is actually intersection of these two lines, isn't it? Write down. Required point. What we require? So required point is intersection of 3x minus 4y minus 16 is equal to 0, this line, and this what we have, 3y plus 4x minus 5 is equal to 0, isn't it? It is actually intersection of these two lines. So if I solve these two lines, you will get common x and y value. That will be the point of intersection. Did you get this? Required point is intersection of 3x minus 4y minus 6 is equal to 0, and what we found just now, that is 3y plus 4x. Can I write in order? 4x plus 3y minus 5 is equal to 0. Now we will solve these two equations. You will get point of intersection. So to these two equations, okay, we'll solve it. Let me write it here now. Okay, I hope I have taken a picture. Let me solve. What we have? 3x minus 4y minus 16 is equal to 0. 4x plus 3y minus 5 is equal to 0. Isn't it? How to solve this two equation? I hope you know how to solve simultaneous equation. 4 into 3. It will be 12x minus 16y minus 64 is equal to 0. 12x. I am making the two equations with a common coefficient. 50 is equal to 0. And when you solve this, negative becomes positive. See, 12x gets cancelled. Isn't it? So this will be minus 25 and this will be minus 64 plus 15, 49 is equal to 0. Isn't it? Let me continue here. First, copy this entire. Solve these two equations. I am solving here. Okay? Pause the video and write down everything. Let me remove this. So, y value will be minus 49 by 25. Isn't it? Minus 49 by 25 y value. And when you substitute y value in any one of the equation, I am writing this directly. You work out, okay? You just work out it. It will be 68 by 25. When you substitute y in any one of the equation, you will get x value. So can I conclude? The coordinates of foot of perpendicular will be 68 by 25, comma minus 49 by 25. Let me conclude it here now. Okay? Conclusion. See, the coordinates of the foot of perpendicular is we'll write in ordered way 68, 25, minus 49, 25. This is the coordinates of foot of perpendicular. All are concept based questions, students. You can solve the problem only by understanding the question properly. Next question. The perpendicular from the origin to the line y is equal to mx plus c meets it at the point minus 1, 2. Find the values of m and c. See, the perpendicular from the origin to the line y is equal to mx plus c meets it at the point minus 1, 2. Find the values of m and c. We take the rough picture first. Perpendicular from the origin to the line. If I take coordinate axis, perpendicular from the origin to the line. Imagine you have a line like this. Okay. This is x-axis and this is y-axis. Equation is what? Y is equal to mx plus c. it at the point. What is the point? Minus 1 comma 2. I know you will not get any negative in first quadrant, but I am taking the points roughly, students. Don't get confused. If you get confused, it's better. Let me take the line in this way. Okay? Origin x. The point meets the line. The line at way minus 1 comma 2. Find the value of m and c. This is the equation what? Y is equal to mx plus c. Equation of line is y is equal to mx plus c, and the point on the line is minus 1 comma 2, and this is actually what? Intersection of a line and a perpendicular from there. So it is right angle. Right? The perpendicular from the origin to the line meets at the point minus 1 comma 2. Find the value of m and c. So equation is given. So we need to find m and c here. Since it is passing through minus 1 comma 2 and this is origin, can you find slope of this line, student? Once you get slope of this line, you can easily find slope of this line. Slope of this line is nothing but value of m, isn't it? And once you get value of m and passing through minus 1 comma 2, you can easily find c. This is the order. So first we will find slope of this line. Okay? Solution. Slope of line joining origin and minus 1 comma 2 is, I am using which formula? M is equal to y2 minus y1 divided by x2 minus x1. So y2 is 2 minus 0 divided by minus 1 minus 0. Did you get the 0? From where? Origin. Okay. So is it minus 2? So this is what? Slope of this line. Then slope of y is equal to mx plus c is what? It's perpendicular, it's negative reciprocal. Is it half? Isn't it, students? If slope of this line is minus 2, the slope of this line will be what? Half. It's negative reciprocal you have to take because they are perpendicular to each other. So m is half, isn't it? M is half. So is given by, let me not give the name as m for this. Don't get confused. Okay? Let me give the name m here. Here I have already written slope of a line joining origin and point is given by this. Then slope of a y is equal to mx plus c is half. So m is half. One of the value already you have, isn't it? Now, this point is on this line, isn't it? Minus 1 comma 2 is actually point on the line y is equal to mx plus c. Then can I say this point should satisfy y is equal to mx plus c? We already discussed about this, isn't it? When any point on the line is given, then that point should satisfy equation of line. Since we have minus 1 comma 2, can I say it should satisfy equation of line? Okay. Now slope of this line is half, m is half. So equation becomes what? Equation is y is equal to half x plus. See, this is the equation now. The rest is I have to find c value. So since the point minus 1 comma 2 is on the line, it should satisfy equation. Let me write. Since minus 1 comma 2 is on y is equal to half x plus c, it should satisfy the line, equation of line, isn't it? Equation of line. So what is the equation? Y is equal to half x plus c at what is the point? Minus 1 comma 2. Substitute x is equal to minus 1, y is equal to 2. That's it. Satisfying means what? X value take it as minus 1, y value as 2. What do you will get? 2 is equal to half into minus 1 plus c. So c is 2 plus half, 3 by 2. C value is 3 by 2. So m is half, c is 3 by 2. Is it 3 by 2? sorry, it will be 5 by 2, isn't it? 5 by 2. We'll take LCM here, 4 plus 1, sorry, 5 by 2. Isn't it? So this is the value of M and C. You can observe all the questions are different here, isn't it? They are not one and the same. The concept is same, but all the questions are different. We'll see the next question. Next question. If P and Q are lengths of perpendicular from origin to the lines, two lines are given. It's a big equation, students. Write them carefully. X cos theta minus y sin theta is equal to k cos 2 theta, one equation. And another is x secant theta plus y cosecant theta is equal to k. Then we have to prove this condition. We have to prove this equation. Okay. So in this equation, what we need to see? In LHS, we need p square and q square value, isn't it? P square value, q. I mean, we need actually p and q value. So that in LHS have to prove it is k square. So what is P and Q? See, P and Q are the lengths of perpendicular from origin to the lines. Equation of two lines are P1. I mean, you know what is a perpendicular distance from origin to the line. It is actually distance between what? Point and a line, isn't it? Distance between point and a line. I mean, can I use the formula D is equal to mod of ax1 plus by1 plus c divided by root of a square plus b square here. So first see solution for first line. What is the first line we have? For line x cos theta minus y sin theta. Let me shift this. So minus k cos 2 theta is equal to 0. This is the first line. And P is what? The length of perpendicular from the origin to the line. This line. Isn't it? For the first line, this is the equation of line. P is given, B is what? P here. Isn't it? And when you see the equation, you just compare this equation with general equation. Ax plus by plus c is equal to 0. Compare these two equations. Can you tell me A value here? A is cos theta. B is minus sin theta, am I right? Coefficient of y is what? Minus sin theta, and C is minus k cos 2 theta, isn't it? And perpendicular distance from the origin, I mean the distance between origin and the line is what? P comma P, isn't it? The distance between origin and this line is P. Similarly, the distance between origin and this line is Q respectively. This is given. I have taken first line. So this is the equation of line and I have written A, B, C here. Did you get the formula? What formula I am using here? Okay. From the origin means the point is what here? X1, Y1 is here. X1, Y1 is 0, 0, isn't it? From origin. So x1 y1 is 0, 0, and this is the equation. And distance is what? And here d is small p, isn't it? D is distance between point and a line. It is given that p. Now can I use this formula, student? This formula. First we consider the equation and just compare the equation with general equation. So extract A, B, C value. And what is given here, P and Q are the lengths of perpendicular from the origin to the two equations of line. So the first one is P is the distance between origin and this line. So I have taken for the first line. See, for the line. Okay, it's better to take for the line. For first line. Okay. Now let me use the formula. What is D? I am using this formula, students. What is D? We have P. P is equal to mod of A is what? Cos theta. X1 is what? 0. This is X1, isn't it? X1, Y1 is 0. So this will be 0. Let me avoid it. 0. Plus dy1. Again, y1 is 0. 0. And C1 is what? Minus k cos 2 theta divided by root of a square plus b square. What is a? We have, students, cos square theta plus b is minus sine, its square will be sine square theta. So is it k cos 2 theta? This is the value of p, isn't it? See, modulus, since we have modulus, negative becomes positive, k cos 2 theta, and denominator is what? Root of cos square theta plus sine square theta is 1, isn't it? So the value of p is 1. This is from first line, where p is distance between origin and the first line. Similarly, let me find the value of q from second line, okay? Pause the video and note down this. Now let me take second line. For second line, what is the line, students? X secant theta plus y cosecant theta is equal to k. So let me write in general equation form, minus c is equal to 0. When you compare this to general equation, a will be secant theta, b will be cosecant theta, and c will be minus a. Isn't it? Again, here x1, y1, because q is length of perpendicular from origin to this line. So point is what? Again, origin 0, 0, and here distance is in the form of q. Q is the distance between them. Again, let me use same formula. I am going to use for second line. So what do you get? Q is equal to mod of ax1. Since x1, y1 are 0, it will be 0. Minus c value is k divided by root of secant square, isn't it? Secant square theta plus cosecant square theta. Root of secant square theta plus cosecant square theta. Now let me simplify q. Let me continue here. So q is, numerator will be k because modulus of minus k will be k, divided by, in denominator, can I take secant square as 1 by cos square theta and cosecant as 1 by sine square theta? And when you take LCM within the root, cos square theta, sine square theta, numerator you will get sine square theta plus cos square theta, isn't it? So q will be k divided by root of sine square theta plus cos square theta will be 1, isn't it? Divided by root of cos square theta sine square theta will be cos theta sine theta, isn't it? So this is equal to k into sine theta cos theta, k into sine theta cos theta, isn't it? So can I write k sine theta cos theta as, let me write it here, k sine 2 theta divided by 2. Can I write k sine theta cos theta as k as it is, instead of sine theta cos theta as sine 2 theta divided by 2? See, we know that sine 2 theta formula is what? 2 sine theta cos theta. You have sine theta cos theta here. If you multiply and divide by 2, the numerator will be what? 2 sine theta cos theta divided by one of the 2 will be there in denominator. So here 2. So can I write k sine theta cos theta as multiply and divide by 2, and what you will get? K into 2 sine theta cos theta. 2 sine theta cos theta is what? Sine 2 theta divided by denominator 2. Why I am writing in this way? Because p value you have cos 2 theta, and if you get q value as sine 2 theta, probably it helps. Okay, so I am writing in this way. I didn't keep till here. I extended this. See how I extended? You want me to write one more step here? Let me write it. K into 2 sine theta cos theta divided by 2. See, I multiply and divide by 2. Now numerator is what? K into formula sine 2 theta divided by. So that is the value of what? Q. So you have both the value of Q and P. We'll consider LHS of the equation, what we need to prove now. Okay. So this is the value of Q. Pause the video and note down. Now, let me take both P and Q value. Okay. So for that, let me take LHS of equation, what you need to prove. So you have P value. P value is what? It is actually K into cos 2 theta whole square plus 4 into Q value, what we have? K into sin 2 theta divided by 2 whole square. I considered LHS. Let LHS, what we have? I substituted P and Q value. See, let me simplify this. This will be K square cos square 2 theta plus 4 again K square sin square 2 theta divided by 2 square is 4. So 4 gets cancelled, and can we take K square common? So what left? Cos square 2 theta plus sin square 2 theta is what? K square into cos square 2 theta plus sin square 2 theta is 1. We have formula, isn't it? Sin square theta plus cos square theta is 1. Where in place of theta you have 2 theta. That's it. So 1. So is it K square, that is RHS. See, we got solution. So first we need to find P and Q value. Later, by substituting P and Q value, we can prove the equation. That is P square plus 4Q square is equal to K square. Copy this. So next class will continue problems, some more problems based on this. Still we have 3 more problems. Okay, we'll see in the next class. Thank you.
Hello students, in the last class we have studied the inertia and moment of inertia, right? And I mentioned this moment of inertia is of radius r and the axis of rotation is along the diameter. The axis of rotation is along the diameter. See, this is how the figure. And moment of inertia in this case is mr square by 4. Okay, the moment of inertia is mr square by 4. In the case of circular disc of radius r, the axis of rotation is along the diameter. Okay, here m is the mass of this circular disc. So it is like this. So the rotation is like this. It is along the diameter, right? The rotation is like this. The second body is a hollow cylinder of radius r. Hollow cylinder of radius r, and the axis is along the axis of the cylinder. The axis is along the axis of cylinder, and the figure is like this. I hope you can imagine this figure, right? And the moment of inertia in this case is m(r square), where m is the mass of this hollow cylinder and r is the radius of this hollow cylinder. Okay. And the third one, a solid cylinder of radius r. The body is solid cylinder of radius r, and the axis of rotation is along the axis of the cylinder. The figure is like this. In this case, the moment of inertia is m(r square by 2). Okay, m is mass of this solid cylinder and r is the radius of this solid cylinder, and moment of inertia is mr square divided by 2. Okay. The next, it is a solid sphere of radius r. Solid sphere of radius r, and the axis is along the diameter. The figure is like this. So like this, and the rotation is like this. And in this case, the moment of inertia value, the I value, which is equal to 2mr square by 5. Okay. Here m is the mass of the cylinder, mass of this solid sphere, and r is the radius of this solid sphere. Okay. Okay. The next body is a thin circular ring of radius r, and the axis of rotation is passing along the diameter. The figure is like this. In this case, the moment of inertia I is equal to mr square by 2. Okay. So like this. Circular ring. It is rotating about the axis which is passing along the diameter. So rotation is like this. Okay. In this case, the moment of inertia is mr square by 2, where m is the mass of the circular ring and r is the radius of the circular ring. Okay. Next, the thin circular rod of radius r. Okay. Here the axis is perpendicular to the plane and passing through its center. So the figure is like this. In this case, the moment of inertia is mr square. It is mr square. See, like this. Okay. The axis of rotation, which is perpendicular to the plane. See, it is perpendicular to this plane, right? The axis is perpendicular to the plane and it is passing through its center. The rotation is like this. In this case, the moment of inertia is mr square. M is the mass of the circular ring, r is the radius of the circular ring. Okay. The next body is circular disc of radius r, and the axis which is perpendicular to the disc at the center. Axis is perpendicular to the disc and passing through the center. The figure is like this. In this case, the moment of inertia is mr square by 2. M is the mass of this disc and r is the radius of this disc. Say like this. Okay. The rotation is like this. Then the last body is a thin rod of length L, and the axis of rotation is perpendicular to this rod and passing through its midpoint. So like this. And the moment of inertia is mL square by 12. M is the mass of this rod and L is the length of this rod. See, like this. So this is rod of length L and the axis of rotation which is perpendicular to this rod. This is our axis of rotation. The figure is like this. Okay. And the moment of inertia becomes mL square by 12. Okay. You don't know the derivation of this moment of inertia of this regular bodies. Just go through it once. And the next concept is law of conservation of angular moment. Law of conservation of angular moment. You already studied what is this angular momentum, right? Okay. Then what is this conservation of angular momentum says? We already studied the expression for angular momentum, right? See, either write small letter L or capital letter L. It's left to you. L is equal to mvr. This is what the equation we got, right? L is equal to mvr. Okay. Then what is this law of conservation of angular momentum says? Okay. It states that if external torque is 0, if external torque is 0, then the angular momentum, then the total angular momentum of the system, is conserved. Okay. The law of conservation of angular momentum states that if the external torque is 0, then the total angular momentum of this system is conserved. That means, according to this law of conservation of angular momentum, the angular momentum of the rotating body about a fixed axis is constant if the external torque is 0. Okay, then according to this law, the angular momentum of the rotating body about a fixed axis is constant in the absence of external torque. That means we can write angular momentum is equal to I omega, right? It is similar to P is equal to mv, isn't it? This is our linear momentum expression, right? Mass into velocity. While coming to this rotational motion, the P replaced by this L, it is angular momentum, and M is replaced by I. This is moment of inertia, and V is replaced by omega. Omega is the angular velocity, right? L is equal to I omega, that is equal to a constant value in the absence of external torque. Or we can write I1 omega 1, that is equal to I2 omega 2. This is a constant value, it's not changing. That means when the inertia of the body is increases, the angular velocity of the body decreases. Okay, the moment of inertia of a rotating body about a fixed axis increases, this angular velocity decreases. Similarly, as omega, the angular velocity value of this rotating body increases, means the moment of inertia is decreases. Totally, the moment of inertia is constant. As I increases, omega decreases. As omega increases, I value decreases. Totally, this value is constant in the absence of external torque. Okay. Then, what are the illustration of conservation of angular momentum? Let's see some illustration. Illustration of conservation of angular momentum. Okay. Consider a ballet dancer spinning fastly. Consider a ballet dancer spinning fastly on her toe of one of the foot. Okay. When he stretches her arms and one of the legs, her moment of inertia is increases. As a result, her angular velocity is decreases, so she spins slowly. Okay, and when she brings her leg and arms towards her body, the moment of inertia of this ballet dancer is decreases. This angular velocity is increases, so she spins faster. Okay. In both the case, the total angular momentum of this ballet dancer is constant. In the first case, I value is more when she stretches her arms and legs, and omega, this angular velocity decreases, so she spins slowly. And when he withdraws her arms and legs, this I value decreases. This inertia, moment of inertia of this ballet dancer decreases, and the angular velocity of ballet dancer increases. As a result, she spins fast. Okay. So, in both the case, this total angular momentum of the ballet dancer is constant. Okay, other example can be when a diver jumps from the springboard, he curls up his body by folding his arms and legs inward, right? So that his inertia value decreases, so that his angular velocity is increases. So this angular velocity increases, so he spins fastly, right? And similarly, when he moving into the water, he stretches his arms and legs, right? So that inertia is more, so he moves slowly into the water because his angular velocity decreases, right? So these are the two illustration we can give for the conservation of angular moment. Okay. Okay, next, from the observation, from the discussion of motion of a body in case of rotation as well as in case of straight line, it is clear that the equations obtained in rotational motions are similar to that we obtained in case of translational motion, right? Let's see what are the comparison of this linear motion as well as rotational motion. Okay, right? Take this list. This is a case in linear motion or translational motion, or we can say straight line motion. And this is in rotational motion about a fixed axis. Rotational motion about a fixed axis. Rotational motion about a fixed axis. Okay. Displacement. The notation for displacement, linear displacement. There is x, right? Displacement is x. And while coming to this rotational motion, displacement, there is nothing but angular displacement. Angular displacement. Angular displacement, that is theta. Angular displacement theta. Okay, next slide. Velocity. The notation for linear velocity is v. That is equal to v equal to x by t. Right, x by t. While coming to this rotational motion, that is angular velocity. Angular velocity. And the notation for angular velocity is omega, which is equal to theta, angular displacement by time. The third, acceleration. Acceleration. The notation for acceleration is a, which is equal to v minus v naught divided by t. Final velocity minus initial velocity by time. And in case of rotational motion, it is angular acceleration. Right, angular acceleration. Angular acceleration. And notation for angular acceleration is alpha, which is equal to, in place of v, we have to write omega, omega minus omega naught divided by t. Okay, there. Mass. Notation for mass in linear motion, it is m. In rotational motion, the moment of inertia is a rotational analog of mass, right? So moment of inertia. Moment of inertia I. The moment of inertia plays similar role what this mass does in linear motion. It plays similar role or what mass does in linear motion. Okay. Next. Force. Force. F equal to m into a. F equal to m into a. Here it is torque, right? Torque. Rotational analog of force. Torque is a rotational analog of force. The notation is tau, that is equal to m into a. It is I into alpha. I into alpha. Next. Work. It is in linear motion, right? So work into x, linear motion, straight line motion. Here it is work, that is work is equal to f into x in linear motion. In rotational motion it is tau into theta. Tau into theta. X is replaced by theta, right? And f is replaced by tau. Okay, the next. Kinetic energy. Kinetic energy. Kinetic energy K is equal to half mv square. This is the case of linear motion. In case of rotational motion, the kinetic energy K equal to half m is I v square, that is omega square, half I omega square. Next, power is P is equal to F into V in case of linear motion, and in case of rotational motion it is rotational power, that is P is equal to F into V, that is tau into omega, it is tau into omega. Then linear momentum. P can be written as P is equal to linear momentum equal to mass into velocity. While coming to rotational motion, it is angular momentum. L can be written as momentum equal to I omega. The kinematic equation is of uniform acceleration in linear motion can be written as kinematic equation. Kinematic equations for uniform motion or uniform acceleration. First kinematic equation we can write V is equal to V naught plus A into T. Second, V square equal to V naught square plus 2AX. Third, X equal to the linear displacement equal to V naught T plus half AT square, right? And the fourth one, X equal to V plus V naught by 2 into T. These are the kinematic equation for uniform acceleration in case of linear motion. What about in case of rotational motion? Listen. The kinematic equations for uniform acceleration, for uniform angular acceleration, right? For uniform angular acceleration, for uniform angular acceleration. Say the first one for uniform acceleration. In place of V, here it is omega, that is equal to V naught. Omega naught plus A into T. It is alpha into T. Right? Acceleration, here it is angular acceleration. This is linear acceleration. This is angular acceleration. Okay. Second. V square equal to V naught square plus 2AX. We can write V in place of V square. It is omega square, which is equal to V naught square, right? So we can write omega square plus 2 alpha into theta. In place of X, here it is angular displacement, and in place of A it is angular acceleration, alpha into T. Okay. Third one, X equal to V naught T plus half A T square, right? In place of X it is theta, which is equal to V naught into T, that is omega naught into T plus half into A into T, half A T square. So it is half alpha T square. T is same, the time value is same in both the cases. Then X is equal to, that is theta equal to V plus V naught by T. It is omega plus omega naught divided by 2 into T. Okay, these are the kinematic equation. This is in the case of linear motion, and this is the kinematic equation for uniform angular acceleration in case of rotational motion. Okay. Then conservation law of momentum. Conservation law of momentum. Or you can say linear momentum. If what it says, if external force is 0, if external force is 0, if external force is 0, the momentum is conserved. The momentum of the body is conserved. You can write mv equal m1 v1 equal to m2 v2. That means mv is equal to constant in the absence of external force. Okay. Then what about the conservation law of angular momentum? Just now we studied, right? Conservation law of angular momentum. What it says, if external torque is 0, if external torque is 0, if the external torque is 0, then the total angular momentum of the rotating body is conserved. can write I1 omega 1 that is equal to I2 omega 2. Right? Or else we can write I omega equal to a constant 1. And equal to, or we can write P can be equal to constant. Okay. Say in the previous class we have studied we have found one expression for angular momentum, right? That is mvr, isn't it? But here we got one more expression. You can take it L equal to I omega. See, L equal to I omega, that is equal to mvr. How? We know I equal to half, I equal to mv square, right? The moment of inertia. Sorry, not mv square. The inertia is equal to mr square, isn't it? Inertia is equal to mr square. And omega, v is equal to r omega. We already studied this expression. V is equal to r omega. In this expression, we can write omega which is equal to v by r, isn't it? We can write omega which is equal to v by r. Just substitute this value here. mr square in place of I, and in place of omega I will write v by r. But r will cancel here. The remaining is m v r. See, same, right? On solving this also we will get the same expression. Okay? Remember these two expressions. Okay. In linear motion, the conservation of momentum is that if external force is 0, the momentum of the body is constant. Okay? In case of rotational motion, the conservation of angular momentum states that if external torque is 0, means the absence of the external torque, the total angular momentum of the rotating body is constant, is same. That is I1 omega 1 equal to I2 omega 2. These are very simple. Once you know the equation in case of linear motion, easily you can write the equation in case of rotational motion, right? Just replace this x by theta and v by omega and v naught by omega naught. Then acceleration is a by alpha, f by tau. Okay. Once you know the equation in linear motion, you can write the equations in rotational motion. Then say the relation between linear terms and rotational terms. The relation between linear terms and rotational terms. And rotational terms. terms and rotational terms. Displacement. Displacement is x in linear motion, and in angular term that is angular displacement. Angular displacement is theta, right? Angular displacement theta. Then what is the relation between this angular term x and the angular term theta and linear term x? That is x equal to r into theta. X equal to r into theta. Where r is the radius. So r is equal to r. And velocity v. And here it is angular velocity. Angular velocity is omega. The relation between these two is v is equal to r omega. V is equal to r omega. Right? V is equal to r omega. Next, acceleration. Acceleration is area, and in angular case it is angular acceleration. Angular acceleration alpha, right? And the relation is a is equal to r alpha. So yeah, is equal to r into alpha or alpha. Mass, it is m, and here it is moment of inertia. Moment of inertia I. What is the relation between this moment of inertia and mass? That is I is equal to nr square. Where r is the radius of the rotating. Or distance of the particle from the axis of rotation. Linear moment. Linear moment. Speed. Right? But coming here, it is angular momentum. Momentum, rotation is L, and we know the relation between this P and L, right? What is that? Yes, angular momentum is equal to R cross P. Is R cross P. Cross product of radius vector, opposition vector and linear moment gives angular moment. Next, force. Force F, here it is torque. Notation for torque is tau, and the relation is tau is equal to R cross F. R cross, yeah, it is a cross product of position vector and force. R cross. Once you restore this, it will be easier for you. Okay. Okay, here we finished our theory part. Let's move on to the numerical part. Questions already sent to you, right? Point whose position vector is this. We are supposed to find the value of tau. We know the relation between tau, this force F and this position vector, right? What is that? Tau is equal to R cross F. If you are finding the cross product of this two, it is R cross F. Be careful, R cross F. If you are finding the cross product of these two value, you will get the value of tau. That is the required value, right? We need to find the value of tau by the cross product of position vector and force. Okay. Tau is equal to determinate. We already studied, right, how to find the cross product of any two vectors, isn't it? First, we have write I, J, K. I is a unit vector along x-axis, J is a unit vector along y-axis, this is along z-axis. R cross F, isn't it? So that we have to write the R values first. Okay. What is the coefficient of I in R? That is 7. First write 7. Then here it is 3. Here it is 1. Be done. Right. Then cross F. So that here we have to write the coefficient of I cap is -3. The coefficient of J is 1 and the coefficient of K is 5. Okay. Then we have to find the cross product of this. How? Tau is equal. First we have to find the coefficient of I cap, right? So write I cap into. So neglect this term. The remaining is 3, 1, 1, 5. First what we have to do? 3 into 5. 3 5s are 15. Minus. 1 into 1 is 1. Okay. Then minus j cap into Now we are finding the coefficient of j, right? So neglect this term. Remaining is 7, 1, minus 3, 5. First we have to do 7 into 5 is 40. 40 minus 7 into 5, 40 minus 3 into 1. It is minus 3, which already we have one minus, so it is plus 3. Right. Then plus k cap into. Leave this column. Remaining is 7, 3 minus 3, 1. 7 into 1 it is 7. minus 3 into 3, 9, but here minus 9, so sorry, minus value, so it is minus 9, but already one minus, so it becomes plus 9. Right? Okay. Oh yeah, here it is, sorry. 7 into 5, the value is 35, isn't it? 35, sorry. 7 into 5 is 35. Be careful, correct it. 7 into 5 is 35. 7 into 5, 35. Plus 3. Okay. Here. Tau is equal to 14. 14 I cap minus 38 j cap and plus